In order to find the domain of a function, there's two ideas that we need to think about. One is we're not going to be dealing with complex numbers, at least not until later in the semester. So whatever's inside the square root needs to be a positive number. Also, there's no division by 0 ever, and so the denominator cannot equal 0. So for the first idea, this, which is inside the square root, needs to be bigger than or equal to 0. So x minus 3 needs to be bigger than or equal to 0, or in other words, not negative. So adding 3 to both sides says that we need x to be bigger than or equal to 3. Okay, so that's one idea because of the square root. The other idea is that the denominator cannot equal 0. So whatever the denominator is equal to, all of this stuff, having it equal to 0, it's a bad idea. It's undefined. And so what we do is say, well, what if the denominator were equal to 0? The square root of x minus 3 minus a 4 is equal to 0. If there's any value of x that will make this true, then we need to throw that value of x out. So we can add 4 to both sides. Square root of x minus 3 is equal to a positive 4. To eliminate the radical, square both sides. So x minus 3 is equal to a 16. And sure enough, there is an answer. It's x equals, let's see, add 3 to both sides, this will become a 19. So we need to throw out that 19. Or another way to say it is, this cannot equal 0, and so x cannot equal 19. Well, you can look at it on the number line and say, here's 0, here's a 3, and there's a 19. According to this part, we need x to be bigger than or equal to 3. So starting here at 3, go to the right forever. But then this part says we need to throw out this 19. So in interval notation, that would then say start at 3 and go to 19, but throw out the 19. So the square bracket means yes, x can equal 3. The round parenthesis means that it can get as close as it wants to 19, but never actually equal to 19. And then on the right hand side, it's going from 19 forever. So go from 19, but not including 19. So just to the right of 19, and then go on to infinity. And finally, union those two together, and that is going to be the domain. And we can use the graphing calculator to verify. So y equals the original function said 2x is divided by, and I need to put this in parentheses so that the calculator understands all of this is in the denominator, the square root of x minus 3. Now stop the square root and then subtract 4, and then one more parenthesis for the denominator. Usually I would say that the window should be set to go from negative 10 to 10 for x and y, but as we saw over here, x out here at 19 is part of what we need to look at, so we need this to go, let's say, at least 19, or perhaps 20. And then take a look at the graph, and the graph seemed to went down rapidly. But one thing to notice is that it starts at 3. At x equals 3, right here, that's where the graph starts. And if we trace, you can actually plug in 3, and it'll just say x equals 3. And when you say enter, sure enough, that is a y value, that is part of the graph. So this square bracketed 3 is correct. Now I want to see the rest of the graph, so I need to change the window and change some of the y values to go lower. So negative 10 wasn't good enough, maybe negative 20. So the graph goes down. Now instead of guessing and checking, maybe I should have put negative 30, negative 40, what I can do is trace and not really watch the graph so much, but instead watch these numbers. It tells you how far down the graph is going. So it's going down into the hundreds, and we haven't even gotten to the 19 yet. So if we go up to 20, we need that going down to oh my. So it went down to negative 1,000, and then suddenly it jumped up into the positive 1,000s. So the y values should be, say, negative 10,000 to positive 10,000. Okay, so now we're really zoomed out. The graph had started at 3 and went down. It goes down, 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 and it's split right here. This is called a vertical asymptote. I'm pretty sure that's where x equals 19. Trace and put in a 19. Sure enough, it says the graph is undefined. Out here at 19, there's a split in the graph. Part of it goes down to negative infinity and part of it goes up to positive infinity. But at 19 itself, it's undefined. So 19 should not be in the domain.